Welcome one and all to this era. Welcome one and all to this second episode of D and Other D with me, Mike, and me, Lilith. That's what you say.
Yeah, and me, Lilith.
And me, Lilith. Yes. And we are working on our little slidey piece puzzle. What we're going to be doing today is we're going to be separating the picture. Now this is going to be complicated. So what we're going to try to do first is go through the math. I've already researched the math. I've already written it all down. And it's all ready, the logic and the math. But we're going to go through this with Lilith, who's very little. All of the documentation to this is all going to be available in the project, which we are also going to make available at the end. Okay?
Okay.
Alright, so I've created an Excel file which I've put inside this folder called Documents. Let's take a look at it. Okay, so there's a lot of stuff going on here. But what I want you to look at is this box over here on the left, okay? You can see that the box is made out of smaller boxes, right? I've colored them differently from one another just to indicate that they are different boxes, okay? These are going to be the slices we're looking to do. So in this particular picture, we're going to look to slice it 4 times horizontally and 4 times vertically. You see that?
Yep.
So how many small boxes will you find if you slice both dimensions by 4? If you want to have 4 on both dimensions, you need to multiply how many you have here by how many you have here. So here we have 4 boxes, and here we have 4 boxes, and 4 times 4 makes
16.
16. We have 16 boxes here in total, okay? Now, the thing that we need to remember that's extremely important is that every picture is made up of pixels, right? And the pixels are these little boxes that contain colors. In this case, for example, the first 4 boxes, 0, 1, 2, and 3, are this light gray. And the next 4 boxes, 4, 5, 6, and 7, are this dark gray, right? Right. So, the numbers go like this. From the bottom left corner, they go all the way to the right of the picture, and then they go up a row. And then all the way to the right of the picture, and then up a row. Then all the way to the right, etc. Right? So why is this complicated for us? Well, because the problem is we need to split it and get this little box. Thing is, as you can see, the numbers don't go in order. 0, 1, 2, 3, but then 4 is in another picture. We need to go get 16, 17, 18, 19, and so on. Right?
Yep.
So it gets a little bit complicated. Okay, so we are going to figure out the correct mathematics, or at least one way of solving this, that will allow us to get to this result. Okay, now the way we do all of the pictures is going to be through loops. Okay, we're going to use various loops. So think about it. Don't look at the stuff inside each box, just look at each box, right? The order in which we want to go is horizontal, so it would be this box, then this box, then this box, then this box. And then, where do we go?
This box, this box, this box.
No, we're not going to stay there on the right. We're going to go left to right. So first we go horizontally, and then we go up by 1, and then horizontally, and then up by 1 and horizontally. Do you understand?
Yep.
Okay, so in order to do this, it means we're going to have to do 2 loops, one horizontal and one vertical. And they need to be nested. This means they need to be inside one another. So which loop do we start with first? Because we're going this way, right?
So vertical?
Well, vertical will be this way.
So horizontal.
Ironically, you are correct, though. We start with the vertical. And here is why. I'm going to explain. You need to remember how loops work in code. Okay? And so we need to think the way a computer will. So let's do a new page here. Doesn't matter. And then new over here. And then I'm going to lower the size of this. So one loop. To start a loop, we need to write the word 4. Whoops. Wait. Let me undo this. We need to write the word 4, right? So it's 4. And then we need to say a certain iterator. Let's call it A for now. We're going to say that A is 0. And then we're going to say a certain condition. Let's call it C. And then we're going to increase A. Now the stuff that is inside here will repeat. Right? Now inside it, let's create another loop. And we're going to say for B, again starts from 0. It has another condition. Let's call it C2 and call this one C1. And then B++. So B goes up. Now the stuff that's inside of here repeats. But which one will repeat first? If you think about it. So you go in here, right? Then you go in here. Then this loop needs to be completely finished before we go to the next A, right? So remember in our logic, what do we want to do first? Horizontal or vertical? We go like this. No, we go horizontal. We go like this, right? Yeah, okay. So if we go horizontal first, then surely it means that this one needs to be done first, the one that's inside. So B is going to be our horizontal. So this is our X. And A is going to be our vertical. So this is our Y. Okay?
Okay.
So let's go and quickly write the code at least for this. We also need to know by how many. What is our condition? So our condition for the X is it needs to be lower than the amount of cuts we do, right? Which in this case is 4. And for the Y, it also needs to be lower by the amount of cuts we do, but vertically. And in this case, it also is 4. Remember that in our game, it can be any numbers we choose, okay? In this case, it's 4 and 4. So anyway, let's go and write the code. So if we open split here, actually, I think we may have already written this, at least in part. So split sprite. Okay, so here it says Y is 0, Y is lower than the Y box size. Is that correct? Let's see. We're dividing resolution by Y count. No, because we need to do the boxes first. So I want you to change this. I want you to type box Y. So lowercase b, box, and now uppercase Y. Box, uppercase Y. Now copy this, paste it here, and here. And copy Y count, and paste it here, right? So I've actually created my own version here, okay, but it's the same thing. Now for the X instead, we need to do box X. So here you need to replace this with box X. Box shift X, and now copy it, paste it here, and here. And here we can go with copying X count. So copy and paste it here. Save. Okay, so what have we found out? Once we do these two bits of the loop, we find ourselves here. Because remember, the beginning of the loop, X is 0 and Y is 0. So we know we have this box. The next set of the loop, what happens? X becomes 1, right? What happens to Y? Does it change?
No.
That's right. Y stays still for now. So X1, Y0, right? And the next one? What value is X going to be?
3.
Why 3? If it was 1 before.
2.
Yeah, that makes sense. What about Y? What happens to Y?
Still doesn't change.
That's right. What if we go here? What coordinates are we going to have? X is going to be?
3.
And Y?
Still.
So 0. And what about the next one?
This time Y goes up by 1 and X stays still.
So X is going to be 3? X3 would be here. So what happens to X?
X.
It's the first row, first box, isn't it? In the row. So X is?
X is 0.
That's right. So you have Y1 and X0 and so on. And if you look at our loop here, So y starts at 0, x starts at 0, so they're both 0. Then the first one that goes up is x, so it becomes 1. Then it goes up again, 2. Then it goes up again, 3, while y is remaining the same, right? Now, this loop finishes because after 3, x is going to be 4, which is not lower than 4. Okay, so we exit the loop. And then, however, we're still inside the first loop. So we need to now go up on the y. And the x is going to start over from 0 again. Okay?
Okay.
Now that we found the right box, okay, what we need to do is now we need to loop through these, through the pixels. Now the way we're going to do is we're also going to loop horizontally and then vertically, just like that, okay?
Okay.
Right? So we're going to have to use these limitations, and we have found the starting point for all of the boxes already. This means at this point in our code, we should be able to prepare all of the pieces that we will need to sort of fill in, because we're going to need a set of colors. Okay, color, box colors. We're going to need the colors to be built. All right, so let's go here, and you see how we built colors and we got them from the picture? Now we need another set of colors. So you go color, array, so color, and now square brackets, space. Call this one box colors, so box, lowercase, and then capital C, colors. Yeah, S equals new, NEW. Now just press the space key, and now tab. Now a square bracket, we need to tell it how many pixels it's going to have. And we know this because we know the area size, which we calculated last time, because we calculated the box size first, which we took by dividing the resolution on the x by how many slices we have, and then dividing the resolution of the y by how many slices we have, and then we multiply them together to get the area size. So here you can say area size. And there it is. And put a semicolon here. Let's rename area size. This. Let's rename area size to box area size. So press this key that says F2 up there. And now type box here. And now capital A. And we've changed them everywhere. Okay, we don't need this debug log anymore. Okay, so the box colors get reset. Now, they will get rebuilt every time, so I don't think we need to reset them here. Yes, I reset them every time apparently. We can do that too. So we're gonna do this instead. Now cut this. And right here you can say box colors. Colors. Yeah. And now paste. Control V. So yeah, save. Now we've reset this, and that's good. Now one more thing we are going to need is we're going to need a way to go step by step. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Right? So we're gonna call this one a counter, and it's an int, it's a number. So we're going to say right here, you can say int space loop counter, LOOP, counter with a capital C. Semicolon. Now we're going to give it a value. Copy it. Paste it here. Equals. Which value do we start from? Which value do we start counting from? With computers, usually.
0.
That's right. So put a 0 and then a semicolon. Save. Now we're going to need to count them one by one as we continue. Okay, finally, we're now ready to loop between the pixels. Right? Now, we should know how many pixels we're going to have in each box. Yes, we do. We've already calculated them before. X box size and Y box size. Again, just like when we're looping through the boxes, we're now looping inside in the pixels with the same order, starting from vertical and then going horizontal. So let's type for, F-O-R, Now hit tab twice. Okay, int, change this I to Y. Yeah, hit enter. And now change the length to Y box size. There it is. Okay, now you can copy all of this, pasta it in here, and this time this needs to be X. So hit it, the letter X. Here too. And here as well. And this one changes to X too. Save. Alright, and now we're going to go through all of them. So the last thing that we need to do now is the most important thing, which is figuring out, as all of these numbers change, how do they affect the final number that we get? Because we want to get the correct number. Remember, 0, 1, 2, 3, and then I want 16. Okay? 4, 5, 6, 7, and then I want 20, right? I don't want 8, I want 20. That's what's important. Okay? So, what we're going to need is, I've realized we could have gone for a simpler solution actually just now, but we're going to go with a complicated one. Okay, the one that I had picked. So first of all, I need you to think about this. Let's think about the deepest loop we have. This one, the first one, the one that goes by box. So the way that one works is it starts here, by row. So this one starts on this row, right? This is row 0. And then it goes to this row. This is row 1. So if this is the starting point of row 0, this is the starting point of row 1. Look at its value, 64. How many boxes is all of these? What do you think? They're all in order, right? How many boxes is this going to be in total? It's really not that difficult. Remember.
64.
64, that's right. So there's 64 boxes because it's 4 times how many there are? 4. Right? 64. Now that 64 we can get from multiplying the box area size by how many boxes there are. Right? Box area size times X count times Y. Well, because when Y is 0, anything by 0 is 0. When Y is 1, 1 times 64 makes 64. When Y is 2, 2 times 64 makes 128. And when Y is 3, 3 times 64 makes 192. See? Pretty easy. Okay? Cool. So, let's do this. We're going to say, well, first of all, we're going to need to choose the box color. So copy box colors, paste it here, square bracket, loop counter, no, inside here, loop counter, close the square bracket, equals. And here you're going to type colors. There it is. Square bracket, oh, wait, that one wrong. C. S. Square bracket, let's go down a couple lines and this. Hit shift and tab. Hold shift and press tab. Okay. Now, so here, what we're going to say is what we just said. So it's going to be box Y, so B-O-X-Y, box Y, there it is, times, which is this symbol over here. Now we said the area of each box, which is box area size, so you can copy this and paste it. And then we said by how many horizontal slices we got, which is X count. So go X count. Just hit, yeah, there it is, there it is. Hit. And then at the end there's going to be a plus. So because we need to keep on adding things. So now we've accounted for the rows. Save. Next, we need to account for which box we're in. Now this one is going to look a bit tricky because look down here. When you start at 0, right, the next box starts at, so it's written, it's in front of your face. 4. The next one
8.
And the next one
12.
So you see they go up by 4 by 4 by 4.
Mm-hmm.
Why? Because there are 4. So the size of the box on the x, that's what we need to be multiplying x by, right? Because if 0 is x, 0 times anything makes 0. 1 times the size is 4. 2 times the size is 8. And 3 times the size is 12. So we're going to find the beginning of each box like this correctly. Okay? So here we're going to say box x. Box, shift x. Then multiplied by, wait, let's put a space here. Another one over here. Multiply, we said by x box size. So copy this. Paste it here. Then plus. Alright. So now we need to worry about all of the pixels one by one. Again, we need to start vertically first. Okay? Now this one's gonna be a bit odd. But look here, once you found the start, what's the next value if you go up by 1 on the y?
Mm. 16?
That's right. 16, which is the length of the entire row. So let's see if 16 plus 16 makes 32. Yes, it does. It's the length of another row. So we need to add y of the pixels multiplied by the entire row. Okay, so let's try a bit more complicated. What if you're on 24? Well, the length of the entire row is 16, right? So it would be 8 and then another 8, which gets us to 72. So from 8 to 72. That's 64 addition. That's correct. Okay?
Okay.
So yeah, we need to then add pixel y times x resolution. Okay, so here we called it just y. Let's rename these to pixel y and rename this one to pixel x, just so we don't get confused. Okay, so here then you want to add pixel y, there it is, multiplied by, and we said the entire row's length, which is x resolution. So copy this and paste it here. And finally, we can go up 1 by 1 horizontally, which is simple. 1, 1, 1, right? So I'm adding what? I'm adding the value of x. 0, 1, 2, 3. 0, 1, 2, 3. 0, 1, 2, 3, etc. Right? Therefore, plus pixel x. Pixel x. Okay, save. In theory, we should have now found the correct colors and given them to this. But there's a problem. The loop counter keeps going up, so we need to remember isn't going up, so we need to remember to actually increase it. So copy loop counter and add it here. And say plus, plus, semicolon. Save. Alright, now the loop counter is going up. Good. Let's see all of our logic. So now what we need to do is we finally need to set up our textures and then the sprites. I don't know if you know this, but in 3D graphics, a texture is basically a 2D picture that you splat on top of something. A sprite is exactly the same, but it's the name for the 2D graphics. Now, because Unity 3D is a 3D engine, it does everything in 3D. So you need to make a texture first, and then you convert it into a sprite. It's a bit weird. But what is a texture? What is a picture? Right? A picture is just a flat thing with pixels of certain colors. Let's look at this particular... actually, let's look at this screen. That'll be the easiest, right? So if this is your entire texture, and these are the pixels of the colors, let's look. 0, 1, 2, 3, 4. You have a different color, right? 5, 6, etc. And a different color, etc., etc. Now, what we're doing is we're splitting it by this, right? And it's going to have its own colors, just like that. And there you go. So we need to build a texture that is this. We had a texture that was this. We have split it apart now. We know which colors we want to give to this texture. Now we need to actually make a texture and give the texture these colors, okay?
Okay.
So we're going to create a temporary texture here. You're going to say texture 2D. There it is, texture 2D. And call it, wait, what did I call it down here? box texture, that's it. So call it box texture. Box, and then a capital a T, texture. Texture, semicolon. Save. So we got the box texture ready, and we already have the box sprites, okay? So we can split this texture and put it into these sprites. But we should refresh these sprites. So copy box sprites, paste it here, equals, new, and then space, new, space, tab. Now open a square bracket. We need to tell it how many, just this, how many boxes we're gonna have. Well, we talked about this before. It's the number of cuts by this multiplied by the number of cuts of these. Okay, so we call the number of cuts x count and y count. So it's gonna be x count times y count. So put it right here, x count times, this symbol over here. Whoa, wait a moment. There. And now y count. There it is. Now close the square bracket, semicolon. Save. Alright, so we got the box texture, we got the sprites, everything's ready. Now that we have finally constructed all the boxes here, we'll be able to tell the texture it's going to be a new texture and it's going to have these colors in it. So you're going to say box texture. There it is, equals, new, space, tab, open round. Now this is going to get a bit complicated. We're going to need to give it a few pieces of information. MIP chain, I think that's probably sufficient. This is what we're going to do. So we're going to tell it, actually we're going to omit linear, but we're going to tell it the width, the height, the texture format, and the MIP chain. Now remember that these textures are the small box. So the width is going to be what? It's going to be X box size. So copy that. Paste. The height is going to be Y box size. So copy this and paste. Then we want a texture format. So texture format, you can't know what this means, but it's just going to be, oh, wait a moment. Texture format dot RGB 32. Okay, and then bool false. We don't want the MIP chain. I'm not going to explain what this is at the moment. So save. We've created the texture. Now we have the texture ready, but it's empty. We need to give it its colors. So you're gonna say box texture. Yeah, there it is. Hit tab. Dot set pixels. There it is, the second one. Open around, and you're gonna feed it your box colors. So box colors. Box colors. That's the one. I got it. Now we're gonna close this, and then here we need to apply. So we're gonna say box texture. So the texture gets correctly put together by Unity. Dot apply. Yep, there it is. Hit tab and then open close round and then semicolon. And then semicolon. And now save. And now finally, the last part is going to be actually putting it in the list of sprites. So we're gonna have to go to our box sprite. So copy this, paste it here. Now the question is, which sprite? So we're gonna need a little formula for that too. We're gonna need, remember how the boxes go, first on the X and then on the Y, right? So for the X is gonna be 0, 1, 2, 3. You want this one to be 4, right? But you see that the X is 0 again. So the Y is gonna be 1 though. So if the Y is 1, we multiply the Y by the amount of these, which is 4. Plus X being 0, and we're 4, right? So that's how it works. So we're gonna say box sprites, and this is gonna be box y, copy, paste it, multiplied by x count. That's the one. Plus box x. So copy this, paste it here, close the square bracket, equals, we're gonna tell it what? It's gonna be this texture, but we need to turn it into a sprite. So it's gonna be create sprite, if I remember correctly. No, wait, let's try with sprite.create. So type sprite. Okay, there it is. Dot create. Ah, there it is again. And now we need to give it a bunch of information, a rect, pivot, all sorts of stuff. So first of all, the texture. That's easy. That's box texture. There it is. Comma, new rect, space, rect, there it is. Now open around, and here you need to tell it a bunch of information. You're gonna have to tell it the x, the y, the width, and the height. Okay? So for the x, we start with 0. The y, we start with 0. The width, how wide is our picture? Well, it's x box size. So copy this, paste it here. And how high is our picture? Well, it's y box size. So copy this and paste it here. And we got our rect. And then the last thing we need is a pivot. Now the pivot means it's center point. So what's the center point of the picture going to be?
The ship?
Well, no, not of the big picture. I mean of the small boxes. Look here. If I look at this picture over here, right? Or let's say this green one. Where's the center point? Point to it. That's right. It's in this cross in between the pixels. Okay? So that means that the center point is not an int. It needs to be in the middle. It's some kind of division. Okay? Now, we can use percentages. A percentage is a division by 100 sort of thing. And 100% means everything, and 0% means nothing. So 0% would be this corner over here on the x, and 100% would be this corner over here, right? What's exactly in the middle between 0 and 100?
50.
50. 50% is here in the middle. If you do the same vertically, 0, 100, 50. So you get 50, 50. Okay, that's our pivot. It's 50%, 50%. The way you write that is you say new vector 2 0.5 f. That means float, which means a number that's a fraction, not a whole number. And again, 0.5 float. That's 50, 50. And then we close the create statement. And that should conclude our thing. Let me quickly take a look that everything matches what we had before. Yeah, I just wrote it in a bit of a different order, but technically it's the same. That's the same. Apply, box colors, loop counter, etc. All right, so shall we give this a test?
Sure.
Now, before we do, I'm going to show you a test that I've prepared for you here. So you choose one of these boxes you'd like to pick. Which one you'd like to choose? Let's see if our formula works. The yellow one? Okay, so can you tell me the coordinates of that one? What are they? The x is?
I think the x is here.
Yeah, but what would be the x of the box? Right? So if this is 0, or this is 0 on the x, right? This is 1, this is 2, this is?
3.
And what about the y?
0.
Oh no, 0 will be here. Will be here. Right? So come on, Lilith, it's not that difficult. If this box says a y of 0, what's this box is a y of what?
1.
That's right. So this, if this x is 3, the y is?
3.
That's right. So we're gonna go to x3, y3. There's the box. Choose another one at random. Would it be the yellow one or the green one? The yellow one. Okay, so tell me the coordinates of that one. The X is? Yeah, no, I understand that's the beginning of the box. The coordinates I need. So you've told me before how the coordinates work on the X, right? You count from the left. So this box is what X?
This box is x1.
No, 0. You always start from 0.
Yeah, x0. So that one is x1.
What about the Y?
Y. Wait, where does Y start from? Y0, Y1?
Yeah, always. At the bottom. So 0, 1. So this one is?
This one's 2.
2. So I'm going to say X is 1 and Y is 2. There's our box. And you see it's highlighting all of the correct ones. Okay, awesome. So our formula should work according to this. If we put it correctly into the code, it should work as well. So now just pressing play and then hitting the space key should give... Oh, wait a moment. Let's first check how many subdivision we have. Okay, 16. So let's go with 4 and 4, which is what we said before. Okay, and now let's hit play and then hit the space key. There are all of our pictures. Let's check them out. Hey, look, the first one is this box over here. Does that look like it fits exactly there?
Yeah.
Yeah. What about this one? That one's picture number 7. 0, 1, 2, 3, 4, 5, 6, 7. Is that correct?
Yeah.
Okay, let's spot check a few more. 12. Ooh, that's just an empty sky. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That makes sense. It's the only empty sky, right?
Mm-hmm.
Okay, so these should all be correct. Now, let's just stress test it a little bit. Now, one thing that's very important is we need to remember we're working with 2 numbers for the resolution. Do you remember what they are? The whole resolution of the whole picture. 1920
and 18
1080. Yeah, close enough. Now they are going to be divisible by certain numbers. Now we need to be absolutely sure that we choose numbers by which they are divisible. If we choose wrong numbers, it's not going to work because you cannot divide an int otherwise. Okay, if you say, if I ask you divide me exact division 5 by 3, can you do it?
15. Oh, wait,
No, I didn't ask multiply. How many times does 3 fit in 5? Very difficult. You do these divisions with your sister every day or something. How many times does 3 fit in 5?
0 times.
That's ridiculous. 3 is smaller than 5, so it must fit at least once.
1 time.
Okay. Why not 2?
Well, 2 would be 6.
There you go. Thank you. So 1 time. Do you have a remainder?
Yes, 2.
Right. So that means we have a problem. You cannot have remainders, okay? It's something we're going to have to keep in mind when we subdivide our picture. Okay? So let's quickly open the calculator. Okay? And check a few subdivisions. So for example, 1080, right? So the vertical axis divided by 2, possible. Divided by 2, possible. So that makes 4. Divided by 2, possible. That makes 8. Divided by 2, not possible. See, that's not a whole number. So we can't divide it by more than 8 if we wanted to. What about by 3? Is it divisible by 3? Let's check. Divisible by 3? Yes, it is. Is it divisible by 3 again? So 9. Yes, it is. Okay, by 3 again, that would be 27. Right? Yes. What about again? No. So 27 is the smallest we can get. Right? The most amount of things. Whereas 1920, is it divisible by 2? Yes. 2, 4, 8, 16, 32, 64, 128. And then we can divide it by 3 as well, by the way. And then by 5. So we could divide it by a huge amount of pixels, okay?
Okay.
But we could divide it by 3. So you could do, we've discovered that both sides we can divide by 3. Therefore, it will be 3 divided by 3, right? Let's hit space again. And now we should get 9 pictures. See? And it would be just a square like this, then a square like this, then a square like this, a square like, etc. So we can make a 3 by 3 or a 4 by 4, etc. I think the highest we should have for our game would be 16 by 9. Think about it. How many squares is that? It will be 16 times 9 squares. It's a puzzle with 144 pieces. It's a very big puzzle. Could get complicated, right?
Mm-hmm.
But when we do like the different modes or whatever, we can take this in mind. The simplest puzzle, I think a 2 by 2 would be the simplest possible puzzle. Something for babies to do, like Andrew.
Yeah, like half of the ship.
Right? 3 by 3, that's pretty easy too. 4 by 4, you can see it right in front of you, how it would look like. Also pretty easy, right?
Mm-hmm.
We can do a 5 by 5 as well. But then we can, make it a bit bigger. Make it, I don't know, 3 by 6. 6 by 3.
Will we make a menu for a game again?
Well, yeah, of course. We need to do all of the things. Plus, we still need to make all of the interactions. So we've done 40 minutes. We still have plenty of time. Now, the subdivision of pictures is working. So what we need to do now, okay, we can actually move on. I'm just going to delete all of the code that I had written because we don't need it. Okay, this was the code that... Now your code and my code are the same. So, all right, good. So all of this is working. Now, what we're going to do is we are going to actually correctly space these buttons, because at the moment the buttons are placed there before we even place anything else. Like the buttons are already there and we haven't even decided how many cuts we're gonna do, right? That's not good. So we've already created the prefabs for the buttons. Okay, so that's good. We can create them on the fly, but the rows we're not too sure about. Okay, and you notice that it's got a horizontal layout group, so we should have a prefab for the row too. So let's delete all of these buttons, delete these 3 rows, and this row over here will become a prefab row. Let's change the name of the button to cell. Okay? So row and cell. This means that this container over here needs to be populated with as many rows as we need and as many cells as we need. Okay?
Okay.
And the cells go inside the rows, by the way. So we can do that directly in Split Sprite, but I don't think it would be a good idea. We're going to create a new void for this. So call this one void. Yeah, space, and go setup UI. So capital S, setup UI, capital U, capital I. Open, close round. Open a squiggle. Hit enter twice. Close it. Save. All right. Now we're going to create, just as we have the box sprites, we're going to create a list of buttons, probably the same way, but I don't know if our cell here has any code on it yet. I don't think so. We're going to create it right now. So we're going to create a new script, which you're going to call cell with a capital C. C-E-L-L. Okay, hit enter. All right. Now, in the prefab now, we're going to open cell, and we're going to add component cell. That's the script we just created. All right, it doesn't work anymore. You can just drag. They've changed it. Okay, let's put it, yeah, sure. Cell script, right there. Okay, so that's pretty good. Now we're gonna create a public space. Now cell with a capital C. Array cells. Oh, there it is already. Semicolon. Save. So when we set up the UI, the first thing we need to do is we need to destroy all of the cells that we possibly already have. So here we're going to say void, another void, space, capital D, destroy destroy, and cells with a capital C. No spaces. Potato. There are no spaces in code unless you need to go to the next word. Destroy cells, capital C. Cells. Save. Okay. Now here we're gonna say if cells is not null, meaning if it's been set up at least once. Okay. And then here we're going to go through all of the cells. So hit 4. FOR. Tab. And I is fine. And the amount of cells will depend on the cells. So go cells.length. That's it. Dot length. Length is what you use to measure how many things are in an array. Okay, so we're going to go through all of the things in the array and then we're going to destroy them. We're going to say cells square bracket I. There it is. Square bracket I. Well, inside it. There, like this. Dot game object. Okay, and I forgot an important word here, so type destroy. Yep. Okay, there it is. Open around and close around, semicolon. Now, we need to first check if the cell exists. If for whatever reason it's already been destroyed, we need to do something about it. So copy this. And go if, open around, paste it. Control V. Exclamation mark equals. So shift 1, shift 1 and then equals. Null, N-U-L-L. It means if it does exist, that's what this means, then we're gonna destroy it, right? We cannot put the buttons on top of buttons that already exist. We would break everything, okay? So we're gonna call destroy cells, copy it. As the first thing when we set up the UI, paste it. Semicolon, save. Okay, and now we're gonna need to go by box. So we're gonna use the same loop as this. So copy these two loops. And paste them in here. And close and close. Oh, wait, I made a mistake here, save. All right, because we need to set up the rows first and then feed them into the rows. So for that, we're gonna need a bunch of information. And all of that information is missing here, so we need to construct it. So here you're gonna say public transform with a capital T. Use two hands, Lilith. Transform. Okay, there it is. Tab. Call the space and give this one the name row container. So R-O-W, lowercase. And then container is uppercase. Container. Yeah, semicolon. Save. Then you can copy this entire thing. Paste it. And paste it again. Save. Now the second one is going to be a game object with a capital G. There it is, game object. Copy game object again. Paste it here. Row template, capital T, template. Do you know what a template is?
No.
A template is an object that you use to copy from. So when they designed this thing, right? This notebook we're staring at, right? They designed the picture and whatnot. And they prepared it as a mold, and then they copied it many, many times to make this. The first one is a template, okay? So we're gonna have a template for a row, which is gonna be a prefab, and then copy row template, paste it over top of here, and we're gonna call this one cell template. LL. One more L. Save. So we now have a place to put the rows in, the template for the row, the template for the cell. We don't have a place to put the cell in, but that's not a problem because we're going to put the cells into the rows. Okay? So here you want to create a temporary variable called transform. Just type transform with a capital T. There you go. And call this one row transform. Capital T. Transform. Form. Semicolon. Save. Now we're going to create a row every time y goes up or starts, that sort of stuff, whenever we start a row. So it will be here already. So copy row transform, paste it. Oh, I forgot something. We have the cells, but we forgot the rows. We need to delete the rows too. So we're going to need a public row as well. So here you want to say public. Public and transform with a capital T, transform, there it is. Actually, let's do game object, so copy that. Paste it here. I don't think it needs to be public, but never mind. Yeah, let's make it private. We don't need it public at all. In fact, we don't need this one to be public either, I don't think. So copy private again. Paste it here. And maybe here as well. And the row container needs to be public, but these, yeah, they all need to be public. So public game object array, and call this one rows. OWS, semicolon. Save. Now we also need to delete all of the rows. We're gonna do it just for security's sake. Copy. We're going to delete them after we've deleted the cells. So I'm going to use very similar code to this. So if rows is not null, for int I blah 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 goes all the way to the length of the rows, rows.length, and then if rows I is not null, so if the row does exist, then we destroy the row. Because it's a game object, I don't need to say dot game object. Okay, so that will work okay. Therefore, the row transform is kind of not needed, actually, so we can remove that. And here you can say, at the beginning, before we do anything, we're going to create the amount of rows we want and the amount of cells we want. So we're going to copy rows, and we're going to paste it here. We're going to say equals new NEW, space tab, square bracket. Now how many do we want? We want as many rows as y count. So copy y count, paste it here, semicolon, save. So copy rows, paste it here. We're gonna say box y. There we go, equals, and here you're going to say instantiate. This is a fancy word for copy. So we're going to copy from our template. So here you need to tell it box template. Box template. No, we didn't call it box, I'm sorry. Row template, I think. That's the one. So row template. Now, we are going to place it at vector 3.0 for now. So type vector 3.0. Okay, there it is. Dot 0. We're not going to rotate it. So type quaternion, QU. These are difficult words. They don't matter to you for now. Okay, quaternion dot identity. This simply means that the object will not be moved and the object will not be rotated. And then we need to tell it who their parent is going to be. Now the parent we know. It's the row container. So copy this and paste it here. Close the round, semicolon. Save. Now we have the correct row. Now we're going to have to build a cell. Okay, so to build the cell, we're going to go through all of these And that's going to be fairly easy, but first we need to create the amount of cells. So copy the cells. Paste it. And the cells is going to be the same as the sprite. So copy this. Paste it here. Except instead of sprite, it's going to be cell. So capital C, cell. There it is. Save. Okay. And therefore, for this, we're going to need a counter, just like before. We had a loop counter, so let's copy this. Let's paste it here. That's kind of, we don't really need a loop counter, really. We could just use this. Yeah, we could just do whatever. We don't need it. Just copy this bit over here. Paste it here. Copy cells, paste it here. So we're gonna go by the same logic as before that we used for the sprites, which is very important. Equals, again, instantiate. Instantiate. There it is. Now we're gonna copy this entire thing, copy it, paste it, except this is now wrong. It's not the row template, we want a cell template. And we also don't want it inside the row container, we want it inside the row. So copy this, paste it here, dot transform. So this is going to be its parent. However, it's not happy because it doesn't want a game object. It wants a cell. So we need to say dot get component cell. We're going to assume that each cell has this component on it. Save. Control S. Okay, so let's see if this is now going to work. Simply after split sprite, we're going to call copy setup UI, paste it here, semicolon, save. So every time we press space, it should build the entire button set, right? Because as you can see, I've deleted all the buttons. But first we need to tell it a few things. Oh no, yeah, that's fine. Some kind of Unity error, doesn't matter. So puzzle image is what the row container is going to be. The row template is row, and the cell template is cell. There we go. So we did that. We did a 4x4, right? So try and press space. We're expecting 4 boxes and 4 boxes. There they are. See, they all appeared. Okay. Now let me just tell it not to maximize, so it stays small like this. And now let's change it to 16. Hit space again. Deleted all of them, and it made 16 horizontally and 4 vertically, because that's what we told it. How about 9 vertically? Space. Look at them. That would be a pretty difficult puzzle, wouldn't it? Especially here, it would be super hard to do. Right? You understand why you tend to avoid having just one color in the puzzle? Because it's so hard to then figure out where things happen. Right? So you would want a picture with clouds, for example, or anything that helps. But if we go back to, Andrew size, for instance, there you go. You have these pictures.
That would be a very easy puzzle.
Sure, but it's good for babies, right? Babies needs to start very simple. 3x3. There you go. But you can see it all works perfectly. Problem is, all of these pictures aren't really right, so to speak. Okay? Because these buttons here don't have anything in them. They're empty. So if we look at our clone here, right, you see it's got this color, it's got this selection and whatever, but it doesn't really contain the picture itself. The picture we see in the background, right? If we were to hide the picture like this, you wouldn't see anything, which is what we want. So now what we're going to do is we're going to add those pictures here, okay? That means we're going to go and have to modify our cell. So problem is the graphics in the cell are already here. So that's not really good. We want that selection graphic, but it needs to be on top of the other graphics. So inside the cell, we're going to create a UI image. Like that. Let's open it so we can see it. There it is, and there's the image, which is ginormous. So we're going to fit it all like that. There's our image right there. Okay, don't know. All right, of course. And this one fits all. Ah, darn it. There. Finally, I've been able to fit the entire image. Now, I'm not going to put anything on this image for now, but we're going to feed it the sprite we want, okay? We're going to call this one box. And then we're going to duplicate this image, and we're going to call this one selection. This one will be that border that you saw, okay? This border that we have over here. So we're going to copy this component. We're going to remove this component and paste this component as new right here, the highlight. Let me change its color so you can clearly see it. See? This border. That's our usual selection border, okay? And then in the cell, we're going to remove this component. And now it's going to say, hey, I don't know what to color. And we're going to tell it, we want you to color the selection. So now it's going to go color this selection, but it will leave this box graphic alone, okay? Now inside the cell, here we're going to say public void space setup capital S setup cell with a capital C. Open close round. Open a squiggle, hit enter twice, close it. Save. Control S. So what this is gonna need, oh, let me see here actually. So the cells, that's fine. Oh, the sprites should be public though. So let's copy public and paste it here. We're gonna need the sprites. What we're gonna feed the cell is an int ID. So it's gonna receive its own ID. Remember that all of the boxes are numbered, right? Bottom to top. Well, bottom to top, left to right. So 0, 1, 2, 3, then 4, 5, 6, etc. Right? So we're going to send that number to this guy so it knows which number it is. Here you can create a public, public int box ID so we can remember it. Okay? Let's also give it a default value of -1. Now, when we set it up, we need to apply the correct picture. Now, remember we have an image inside of our box, inside of our cell, which is called box. We need to go get that image. So here you're going to say private image with a capital I. So type image with a capital I. IMAGE. Uh-oh, got a problem. Image doesn't exist. And the reason why it doesn't exist is because you don't have it among the libraries that are available. So here we're going to type using Unity Engine UI. And now image is turned yellow and it exists because we found it there. And you can call this one box image. Box image. Semicolon. So the first thing we do, copy box image, paste it here, equals, and we're going to say box image equals transform, there it is, dot find, there it is, open around, quote, now what did you call it? Box, capital B box. Box. Close the quote. Close the quote. Close the round. No, you didn't close the quote. No, you did. Close the round. Semicolon. Oh, we forgot to get the component image. Okay, save. Get component image. Now we got the image. And now we can finally give it the correct ID. Copy box ID. Paste it here. Equals ID. Lowercase. Just ID. Semicolon. Save. Now that you have the box ID, you can say, finally, we can give the box image the correct picture. So copy box image. Paste it here. Dot sprite. We forgot something. We forgot to tell our game manager that it's a singleton. So we're gonna need here a public static game manager script. And then here we're gonna say void awake. And here I want you to type script equals this. Do you remember what awake is? It's a method that plays right away when your game starts. Equals this. THIS. Because there's only one game manager in our entire scene, okay, we're gonna make it a single script that everybody else can access. By doing this little trick, you can do it. So here you can say sprite equals game manager script puzzle sprites, no, box sprites, and now which one? Box ID. And now this box should have the correct picture. So let's go back to Unity. You see the box currently has a bright white picture with nothing going on, right? We're also going to tell our puzzle image that this image, for now, is just going to be turned off. So we see nothing, okay?
Okay.
If I hit play now, and our game manager says, hey, we want 4 by 4, and I press space, boink, it all exploded. That is a bit strange, but let's take a look. There's the cell, and the box has no sprite. Did we forget to call setup cell? Yes, we did. We need to tell it to set up the cell right here. Okay, so cells, blah blah blah, setup cell, and it's going to be this number over here. Okay, a bit silly that we keep on recalculating this, but whatever, it'll do for now. Okay, let's hit play one more time. Here's where we're gonna stop. Whee! It has worked, but there's a mistake. What's the mistake?
This boat is already built and the place is all over the...
Well, the fact that it's built is fine. We'll worry about that later, but something else is going on. What's upside down? Are there... Is it horizontally correct?
No.
No? Looks horizontally correct to me. This does look right. Horizontally, doesn't it?
Yeah, horizontally, but vertically, no.
So what's the problem with the order? Is it exactly backwards? Or is it random, or what?
It's not random. It's not exactly backwards. This part is backwards, but this part isn't.
Yes, it is backwards. Look. The top one is supposed to be the bottom one. This one's supposed to be the second, the third, whatever. So 0, 1, 2, 3. It's going up. It's downside up. Now, I don't recall if it's possible for us to tell it the child alignment, but let's try lower left. No difference. The order. I don't know that it's possible to tell it the order like this. So we need to simply remember to sort them correctly. Meaning row 0 needs to be the last one. Okay? I don't remember how to change the order. Let me see here. It's something like set parent order, set order, set order. Wait, transform set. Aha! Set as last sibling, set as first sibling. So we're simply going to set everyone as the first sibling, because 0 will become the first sibling, then it gets pushed down, and then pushed down, and so on. And this one should work. Let's see. Let's see. There. That's much better. So, but the thing that's important to notice, okay, is that now these are actually separate. So if we hide this one, see, it's gone completely. Like the entire box. disappears. See?
Mm-hmm.
So we have the picture separated into 4 separate parts. For now, we don't yet have the whatchamacallit, the interactions, but that'll come next time. But we do have a picture with boxes, and we can highlight the boxes just like that. And the picture is all put. Ooh, look, there's even a bug. You can see a little empty dot right there. I wonder if it appears in this. Yes, it does. Yeah, there they are, all of them. These little cuts sort of thing. And I don't know that there's a whole lot we can do about that. Because the spacing is 0 and the padding is 0 too. Not a whole lot. I suspect there's something. Does this have pixel perfect? No. Let's try pixel perfect. Yeah, it's fixed it. Okay, so we're gonna just tell the canvas you're gonna be pixel perfect. So let's try it one more time. And there they go, no seams anywhere, it's looking fantastic. So we'll be able to select them and flip them. Except flipping is not gonna be quite as simple as you may think. By the way, do we want to animate it so that it sort of slides? So if you click on this one and then this one, it slides. Is that what you want to do? Yeah? Well, that's not going to be that easy. Dun, dun, dun. Yeah, we're going to probably have to make a copy of it on the fly and then drag it on that side. Something like that. We could also make them dance when you select them. So they dance a bit. Bloop, bloop, bloop.
Move side to side.
Just a little bit.
Or maybe you hold the mouse down and you move it in what place you want.
Oh, that's what you would like to do? Yeah, that makes sense to me. So that basically you click and hold, right? And then you drag them. Yeah, okay, that makes sense to me. We're going to have to ditch the button system then. We're going to have to make our own, but it should work dragging and dropping. Again, there's going to have to be some illusion there. And it's not going to be as simple as you think. In fact, it's going to be quite complicated. I'm going to have to do some research on that. Okay, well, thanks everyone in the YouTube crowd for watching, and we'll see you again next time. Bye. You're supposed to say bye.
Bye.